look at the integral cheat sheet. Now this cheat sheet is quite helpful when looking at integral problems. It helped me quite a lot when I was studying integrals and getting me through the integral section. So feel free to pause the video at any time, look at the examples that I'm doing. Also ensure that you take note of all the rules and the properties that I'm going to show you in this video. Stay tuned towards the end of the video because I will take you through the bonus of some rules with regards to the trig integrals, which are quite important because those are a bit more difficult to remember and a bit more difficult to solve. And it will be a case, or most of the time you will get a case where you might need to prove those type of integrals. So let's get into it. The first integral rule or property we're going to look at is called the constant rule. So this is the constant rule. And this rule basically says if you do the integral or have the integral of a, which is a constant, dx, this is basically equal to ax plus c. Take note, right? So it's basically a, which is your constant, and c. So ensure that you always include c in your integral because the derivative of any constant is 0. That's the reason we need to ensure that we do have a c to cater for that that constant. So let's look at this in an example. So let's say we want to find the integral of 4 dx. So this was basically equal to 4x plus c. Don't forget the c. Quite simple, right? Let's look at another one. Let's say we have the integral of pi dx. Once again, quite simple. Pi here is a constant, so we're going to have pi x plus c. Let's try one more, right? So let's say we have the integral of e dz. That's simply equal to ez plus c. Okay, quite simple. And the most easiest rule for you to remember, the constant rule. If you have any constant, it's equal to the constant x plus c, and that's basically it. The most simple and the most easiest rule to remember. Let's move on to another rule. We're going to move on to the next rule, which I want to show you, which is called the power rule. So the power rule. Okay, so the power rule is basically we have the integral of x raised to the n dx, and this is basically equal to x n plus 1 divided by n plus 1, and of course plus c. However, if you look at this, we need to ensure that this is only true when n is not equal to minus 1. Now the reason for this is, if you can see, if you place minus 1 in the denominator, you will end up with 0. So this n becomes undefined. Okay, so just remember that the power rule xn dx is equal to x n plus 1 all divided by n plus 1 plus c, as long as n is not equal to minus 1. Let's look at a few examples in this case, right? So let's find the integral of x squared dx. That's simply equal to x. N here is 2, so this is basically your n value. So it's 2 plus 1 divided by 2 plus 1 plus c. Don't forget the c. And simply put, this is x cubed all divided by 3 plus c. Simple, eh? Let's look at another example. Let's say we have the integral of x raised to the 5 dx. So what is n here? N is 5. We're going to have this as x 5 plus 1 all divided by 5 plus 1 plus c. And this is equal to x to the 6 divided by 6 plus c. Quite easy, right? Power rule. any integral that you can see here that has the is raised to the power, you need to use the power rule. Let's do another example. Let's do one where we have the integral of 4x cubed dx. So we can see here, this is the x is raised to the power, so we need to use the power rule. First thing that we need to do is remove the constant, so we can have 4, the integral of x cubed dx. Take note of this. I will show you this rule later on in the video. So this is equal to 4x. We can see 3 is our n, so this is 3 plus 1, all divided by 3 plus 1 plus c. So this is basically 4x to the 4 divided by 4 plus c. And if we look at this, we can see that we can simplify this further. The 4's and the 4 can cancel out, and we'll have x to the 4 plus c. Always remember at this step, try to simplify as much as you can, because in your test or your exam, you might get an extra mark for having your final solution in a simplified format. Let's do another one. Let's say we have the integral of 8x cubed dx. Okay, we can see we need to use the power rule, so that's equal to 8x, your n here is 3, so it's 3 plus 1 divided by 3 plus 1 plus c. Don't forget the c. And that's equal to 8x raised to the 4 divided by 4 plus c. Are we done? No, we need to simplify. Let's get that bonus mark. So we'll have 2x to the raised to the 4 plus c. 4 can go into 8 2 times. Okay, quite simple, right? Let's do 2 more examples, just so you can get the hang of things with the power rule. Let's use the integral of 7x dx. Now, always take note, this is not shown, right? But we know, right? X is, in this case, it's raised to the power y. Okay, so this is basically equal to 7. The integral of x dx, which is the same thing as writing it as 7x. We know we have 1, so it's 1 plus 1 over 1 plus 1 plus c. And that's equal to 7x squared over 2 plus c. Don't forget the c. We know we can't simplify this any further, so we can leave it as is. Let's do another one. Let's do the integral of 10x dx. So once again, we know the x is raised to the 1, so that's equal to 10. The integral of x dx, which is 10x. The n is 1, so it's 1 plus 1 divided by 1 plus 1 plus c. And that's now going to be equal to, or that's going to give us 10x squared divided by 2 plus c. And this is not our final answer. We know we can simplify it in this case. So this will be 5x squared plus c. Okay, so that's basically the power rule. Quite important, the power rule and the constant rule. You'll be using it a lot, as you'll see as we continue going on in this video. You'll see how we can combine the different rules in order to solve the problem. So the next rule that I will be taking you through is something that you will most likely use in almost every example that you see, especially when you have polynomials involved, which will be the sum and the difference rule. So let's get cracking into the sum and the difference rule. Okay, so let's get cracking on with the sum and difference rule. So the sum and difference rule is also quite basic. So it basically says that if we have the integral of x squared plus minus x dx. We can rewrite this as the integral of x squared dx plus or minus the integral of x dx. Okay, quite simple, quite easy to remember. So let's look at an example, right? You'll use this a lot with polynomials, so let's do a polynomial example. So let's find the integral of let's say x squared minus 5x plus 6 dx. So let's follow this rule first. So we can see that there's negatives and positives, so plus and minuses. So let's use this rule and rewrite this equation. So we rewrite it as the integral of x squared dx minus the integral of 5x dx plus the integral of 6 dx. Okay, now we can see we split up this polynomial into three integrals that we need to find, and if you look at them quite carefully, you can see that for the first one here, it's x to the 2, which means we can use the power rule. For the second one here, it's x to the 1, which also means we can use the power rule. And then for the 6 here at the end, we can see that it is a constant, which means we can use the constant rule. So let's do that real quick. So this will be equal to x, the n is 2, so it's 2 plus 1, all divided by 2 plus 1, minus, we know the n is 1, however we pull out the 5, so we have 5x 1 plus 1, all divided by 1 plus 1, plus the constant rule for the 6, so that's just 6x, and don't forget the c, right? So if we were to simplify this, we'll get this as x cubed over 3 minus 5x squared over 2 plus 6x plus z. So that is quite simple, right? So breaking it down using the sum and the difference rule, we're able to then identify that we need to use the power rule for these two and then the constant rule for the last one. Let's do another example. So let's look at the integral of x squared minus 3x plus 6 dx. So let's use the sum and difference rule here. We can see that. So this is the integral of x squared dx minus the integral of 3x dx plus the integral of 6 dx. Okay, this is now equal to, we can see here is the power rule, so the power rule, and here we can use the constant rule. So that's equal to x squared plus 1 over 2 plus 1 minus 3x 1 plus 1 over 1 plus 1 plus 6x plus 6x plus z. Okay, and that's equal to, if we were to simplify this, this is x cubed over 3 minus 3x squared over 2 plus your 6x plus z. Okay, quite simple, right? So let's look at another example. Let's look at the integral of 4x cubed plus 6x squared minus 9 dx. So we can see we need to use the summation and the difference rule here, so let's do that. So if we split this up, we'll get the integral of 4x cubed dx plus the integral of 6x squared dx minus the integral of 9 dx, and that's equal to 4. So power rule, constant rule. Okay, so that's equal to 4x 3 plus 1, your n is 3 here, divided by 3 plus 1, plus 6x, your n here is 2, so this will be 2 plus 1 over 2 plus 1 minus 9 is your constant, so you'll have 9x plus c, don't forget the c, and this is then equal to 4x to the 4 over 4 plus 6x cubed over 3 minus 9x plus z. Is this your final answer? No. Remember to simplify. So we can simplify this. The 4 and 4 cancels out. That's x to the 4 plus this and this cancels out. So it's 2x cubed minus 9x plus c. Okay. Simple enough. Let's look at a few examples. Now, let's look at some random examples actually. So let's look at something like the integral of the square root of x dx. So we've learned three rules thus far: the constant rule, the summation, and the difference rule, as well as the power rule. So what do you think we would use here? It's not that difficult, because what we need to do is firstly rewrite this, and if you can identify how you need to rewrite it, you'll then know which rule to use. So let's rewrite this. This is the same thing as saying the integral of x to the half dx. The half represents your square root. Okay, so now we can see that it is in the power rule form. So that's basically then equal to x half plus 1 all over half plus 1, and that's equal to x half plus 1 is 3 by 2 all over 3 by 2 plus c. Don't forget the c. I forgot the c. Okay, and if you simplify this, you will then get this as x 3 by 2 multiplied by 2 by 3. So if you bring the 3 by 2 up, you invert it, so it's 2 by 3 plus c. So you would now have this as 2 by 3 x 3 by 2 plus c. Are we done? Not yet. So let's simplify, get that extra mark. So that's 2 by 3, and this can be rewritten like we had in the question with the square root. So this is the square root of x cubed plus c. So that's your final answer, your simplified answer. Okay, so don't forget to rewrite it. You will get an extra mark to simplify your answer. Let's look at another one. Let's say we have the integral of the cube root of x squared dx. Okay, so this is now equal to the integral of, let's rewrite this once again. So that can be rewritten as x raised to 2 by 3 dx. Okay, quite simple. So you rewrite this, you now have x to a power, and now you can use the power rule. So this is equal to so that's equal to 2 by 3 plus 1 all over 2 by 3 plus 1. Don't forget the c. That's equal to x 5 by 3 all over 5 by 3 plus 1 plus c. And if we simplify this further, that's equal to, if you bring the denominator up, we'll have 3 by 5 x 5 by 3 plus c. Are we done? No. Just as the previous example, let's see if we can rewrite this in a more simpler form. So we'll have 3 by 5. This can be rewritten as the cube root of x to the 5 plus c. So this is your simplified format, and you should be getting an extra mark for such simplification. Next up, I'm going to take you into a rule that we have been using thus far, which is the multiplication by the constant rule. I won't spend too much time on that rule, as we've been using it and we've been doing it. However, I'll just take you through what it's about and do one example with it. So stay tuned. Let us move on to the multiplication rule by a constant. Okay, so let's go into the multiplication by a constant rule. So this is also quite a very simple rule to remember. So it basically says that the integral of a constant f of x dx is basically equal to, we pull out the constant and then we find the integral of f of x dx. So we have been doing this in the previous examples, so let's just take a quick example, right? This is quite simple to remember and to know. So we say, let's find the integral of 3x dx, and that's basically equal to, like the rule says, let's pull out the constant. In this time it is 3, so let's take out 3, and then we find the integral of x dx. Now you can see that we now need to find the integral of x dx, and x now needs to follow the power rule because this is x to the 1, and so this is basically then equal to 3. Let's plug in the power rule. So we have x, n is 1, so 1 plus 1 all divided by 1 plus 1 plus c, don't forget the c, and this is then equal to 3x squared over 2 plus 1. Quite simple, right? So let's do one more, right? Let's do one more. Quite simple, like I said, so I'm not going to do too many. So let's take the integral of 2x dx, and that would be, we use the multiplication rule. We take out the 2, the constant. We then find the integral of x dx, and this once again we can use the power rule, so that's equal to 2x, n is 1, so 1 plus 1 all over 1 plus 1 plus c, don't forget the c, and that's equal to 2x squared all over 2 plus 1. Are we done? No. Let's simplify. So 2 and 2 can cancel out, and we'll have x squared plus c. So quite simple, right? The multiplication rule, if you go back to the previous examples, you would see that we have been using the multiplication rule. The next rule that I want to go through is the exponential rule, and I'm probably going to spend quite a bit of time on the exponential rule, mainly due to the fact that when I was doing integrals, I did have a bit of difficulty with the exponential rule. So I'm going to take you through the exponential rule, do quite a few examples with the exponential rule, especially to show you how we use all of the different rules that we've learned so far in order to solve the integral. So stay tuned. Let's move on to the exponential rule. Okay, so let's get into the exponential rule. So the exponential rule is basically the integral of e to the x dx, that's equal to e to the x plus c. However, what do we do when we have a constant? So if we have the integral of e constant a x dx, so what is this? This is basically e a, which is a constant, x over a plus c, and this only works if you do have a constant. So please ensure you have a constant. So remember these two rules and you'll be able to work with exponents, or the exponential rule with the exponents, right? So let's do a few examples. So let's do the integral of e to the 2x dx. Now, using the second rule that we saw, we would have this as e to x over 2 plus c. Don't forget the c. Let's do another one. So if we have the integral of e to the 5x, that's equal to e to the 5x over 5 plus c. Quite simple, right? Let's take it up a notch. Let's look at an example where we have more than one constant. So if we have the integral of 6, which is a constant, e2, which is another constant, to the x dx. Now, how do we solve this, or how can we solve this? We see that we have 6 multiplied by e to the 2x, meaning we can first use the multiplication rule. And that means we can take out the 6, and we then find the integral of e to the 2x dx. And now we can find the use the exponential rule to solve for this. So we have 6 e to the 2x over 2 plus c. Don't forget the c. However, are we done? No. Let's simplify. So we have 2 going into the 6, and that's going to give us 3 e to the 2x plus c. Quite awesome, right? So let's look at another example. So let's say we have the integral of 10 e to the 5x dx. So that'll equal to, we can see we can use once again the multiplication rule and then the exponential rule. So we'll pull out the 10 and then find the integral of e5 to the x dx, and that's gonna equal to 10 e5x over 5 plus c. Don't forget the c. And we can simplify that further. So 5 can go into 10 two times. So we have 2 e to the 5x plus c. That's your final answer. Okay, so let's look at another example. Let's look at integral e to the minus 5x dx, right? This is basically equal to, if you use the rule, e to the minus 5x over minus 5 plus c. Quite simple, right? But what we're going to do with this example, let's look at if we can prove that this is actually equal to that. And we're going to go back to basics and use u substitution. So let's use u substitution. So let's say we have u equal to minus 5x. So u is equal to that. Then we know if we derive this, we have du is equal to minus 5 dx. Let's solve for dx. So dx here is equal to du all over minus 5. Okay. So let's take this further, right? So let's substitute into the original. So we have the integral of e to the u, because minus 5 is now u, and then dx is now du divided by minus 5. We can see that we can take the minus 5 to the front, so we can have this equal to minus 1 over 5 into e to the u plus c. Okay, so we can now take this further and show that we have minus 1 by 5 into e. If we substitute back, we'll have minus 5x plus c. And if we want to show this the way we had our first answer, we can show this as e to the minus 5x over 5 plus c. Same thing. So u substitution shows us that solving this is the correct way. Let's do another one, right? So let's say we have the integral of x cubed e x 4 to the 4 dx. Let's use u substitution again. So let u equal to x to the 4, and then let du equal to 4x cubed dx. Okay, and then if we solve for dx, so dx is equal to du all over 4x cubed. So let's substitute back into the original. So now we'll have the integral of x cubed e to the u. Dx is now du all over 4x cubed. And at this point we can see that we did do the u substitution correctly, because x cubed and x cubed can cancel. So we now have the integral of eu du over 4. And that can be rewritten as, we can take out the 4, so we'll have 1 over 4, the integral of eu du, and that's basically equal to 1 over 4. We know that the integral of eu is the same as writing just eu plus c, and if we substitute back, this is equal to 1 by 4 ex by 4 with this u plus c. Quite simple, right? So u substitution can help in a lot of the exponents, exponential, when you're using the exponential rule. So let's do another one, right? Let's do one slightly more complicated, or maybe a bit more confusing. Let's use the integral of e to the x, the root of 1 minus e to the x dx. So easiest way, let's see if we can use u substitution here. Starting in at 10. So let u equal to 1 minus ex. If we do the derivative, we have du is equal to derivative of 1 is 0 minus ex dx, which is basically minus ex dx. So dx, if we solve for dx, that's equal to du over minus e to the x. So let's substitute back, right? So this will now be the integral of ex square root of u du over minus ex. Now we know we did the u substitution correct, as we can cancel these two out, and now we have minus the integral of u. But now let's rewrite u as the examples we had earlier on as an exponent. So that's u a half du. Okay, so now we can use the exponential rule. So this is now equal to minus u into a half plus 1 over a half plus 1 plus c. So that's equal to u 3 by 2 all over 3 by 2 plus c. Don't forget the negative. And if you rewrite this, this will be equal to 2 minus 2 by 3 u 3 by 2 plus c. Let's substitute back. So now we have this equal to minus 2 over 3 into 1 minus e to the x 3 by 2 plus c. Okay, so that's basically the answer. You can simplify further if you want to, make it into a square root 1 minus ex all cubed. I'm not going to do that. I'm going to move on to the next example. So let's look at the integral of 2x minus 1 squared dx. That will equal to what? So what we can do here, we can look at factorizing this. So that can be equal to the integral of 2x minus 1 into 2x minus 1, and that's basically 2x minus 1 squared, right? So this is one way of doing it. Now we can take this further and multiply this out. So we can now find the integral of, if we multiply this out, we would have 4x squared, so 2x times 2x minus 2x multiplied by minus 1 is minus 2x, and then minus 1 times 2x is minus 2x, and 1 times 1 is plus 1 dx. Let's combine the like terms. So we'll have 4x squared, these two are like, so we'll have minus 4x plus 1 dx. So we went from here to here. And what is this? This is a polynomial, which means we can now use the sum and difference rule. So we can find the integral of 4x squared dx minus the integral of 4x dx plus the integral of 1 dx. And now we can see we can once again use the power rule here and here, and then use the constant rule at the end. So this is now equal to 4 into x2 plus 1 all over 2 plus 1 minus 4x1 plus 1 all over 1 plus 1 plus 1x, and don't forget the c plus c. If we simplify this, we will have 4x cubed over 3 minus 4x squared over 2 plus 1 plus c. But we can take this further, so we can have 4x cubed over 3 minus 2 can go into 4 2 times, so it's 2x squared plus 1 plus c. Okay, so this was quite a good example. We were able to go from here where we had an exponent all the way down to use both the difference and summation rule, and then the constant and the power rule. So quite a good example where we combine all the different rules to be able to solve that integral. So let's look at another one. Let's look at the integral of 3x plus 1 into x minus 3 dx. Okay, what do you think we need to do here, right? So if you look at the previous problem, we tried to get this into a polynomial. So let's try to take the same approach. So let's say this is the integral of 3x times x, which is 3x squared, and 3x minus 3, which is minus 9x. 1 times x is positive 1. 1 times minus 3 is minus 3 dx. Now let's look at combining the like terms. That's equal to the integral of 3x squared minus 9 plus x is minus 8x minus 3 dx. So now we have a polynomial, so we can use the sum and difference rule, and that's basically just equal to the integral of 3x squared dx minus the integral of 8x dx minus the integral of 3 dx. Now if we solve this, we know this is not the power rule, this is the power rule, that's the constant rule. So that's equal to 3x into 2 plus 1 over 2 plus 1 minus 8x 1 plus 1 all over 1 plus 1 minus 3x plus c. And if we simplify this, we'll now have 3x cubed over 3 minus 8x squared over 2 minus 3x plus c. Are we done? No, remember to simplify. So 3 and 3 can cancel, so we have x cubed minus 2 can go into 8 4 times, so we'll have minus 4x squared minus 3x plus c. Okay, so quite another interesting integral where we could combine different rules in order to solve such a problem. So let's look at the next one. So let's look at the integral of x cubed plus 4x cubed all over x dx. What do you think we can do here? Since both are being divided by the same denominator, we can rewrite this as the integral of x cubed over x dx plus the integral of 4x cubed over x dx. This is the same thing, right? Because it's the same denominator, So now we can see that the x's can cancel out. So we can now write this as the integral of x squared dx plus the integral of 4x squared dx. This is the power rule. This is the combination of the multiplication and the power rule. So this can now be rewritten as, if you're solving it, 2x2 plus 1 all over 2 plus 1 plus, we bring the 4 to the front, multiplication rule, and we use the power rule. So that's x2 plus 1 all over 2 plus 1, and don't forget the c. This is now x cubed over 3 plus 4x squared over 3 plus c. So can we take this any further? Not really. This seems to be the simplest format, or the simplest form we can solve this integral. Let's look at another one, right? So let's look at an example where we have the integral of 1 over x cubed dx. We can rewrite this the same way we did when we had square and cube root, as the integral of x to the minus 3 dx, right? This is the same as that, right? So let's try to solve this. So we can use the power rule now. So this gives us the advantage of the power rule. So we have x minus 3 plus 1 all over minus 3 plus 1. Don't forget the c, so that's plus c. If we are to solve this, that's equal to x minus 2 all over minus 2 plus c. Is this the simplest format? Not really, because we can show this as, we can bring out the minus 2. So let me just use a different color. So if you bring out the minus 2, that's basically minus a half, and we have x to the minus 2 plus c. But we can rewrite x to the minus 2 as minus a half x 1 over x squared plus c. This is the same as that, similarly of how we wrote it up here. Okay, so let's look at another example. Let's look at the integral of 6x cubed dx. So let's get into a format we can work with. So similarly, we can write it as 6x to the minus 3 dx. And now we can see we can use the multiplication and the power rule. So that's equal to 6x minus 3 plus 1 all over minus 3 plus 1 plus c. Don't forget the c. So that's now equal to 6x minus 2 all over 2 plus c. So we can see that the 2 can go into 6, so that's 3 minus 3 x minus 2 plus c, which is now then equal to, as we did before, minus 3 over x squared. We take this to the bottom because it's raised to the minus 2 power plus c. Okay guys, so that's basically the end of the exponential rule. So quite a simple rule, but you can get quite complicated examples. Ensure that you understand how to do u substitution. I will try to cover that in a future video, but try to understand how to do u substitution. It helps you to simplify the integral, so you can work with it and also identify the other different types of rules you can use in order to look at solving the problem. Up next, I will look at the next rule, which is the reciprocal rule. So this one is also quite interesting. We'll take you through a few examples of it, and we will then move on to the bonus that I've been referring to earlier on, which is all the rules for the for any sort of trig functions. So stay tuned. Hope you still are with me and understanding how we can move ahead with the integrals. Hope you're taking down notes on the all of these different rules. Okay, so let's get into the reciprocal rule. Before I show you the rule, let's try to solve this integral. So let's say we have the integral of 1 over x dx. Now, from what we've learned so far, we can rewrite this as the integral of x minus to the minus 1 dx. This and this is the same thing. And now we can see we can most likely use the power rule. So if we do this using the power rule, we would say this is the x minus 1, which is our n, plus 1 all over minus 1 plus 1 plus c. However, this is then equal to x to the 0 over 0 plus c. And this is incorrect. So we cannot have this, right? Because this is now undefined, and we know that from the power rule it states that n should not be equal to minus 1. So how would we solve something like this? We would use the reciprocal rule, and that rule says that the integral of 1 over x dx is equal to ln x plus c. Okay, quite simple. So let's do an example. So if we do the example of the integral of 1 over x minus 5 dx, that is then equal to ln of x minus 5 plus c. Okay, so this is basically the reciprocal rule, and that's a good example of how we use the reciprocal rule. Let's take another example. Let's do the integral of 6 over x minus 2 dx. So we can use the multiplication or the division rule we had earlier on. We can take 6 to the front, so we have 6, the integral of 1 over x minus 2 dx. So now it's in the format we can use the reciprocal rule for. So we have 6 ln of x minus 2 plus c. Okay, quite simple. So that is basically the reciprocal rule, and that's how you use the reciprocal rule. So next up is the bonus that I'm going to give you, or the bonus tips, which is the integrals for trig functions. So stay tuned and we would go ahead and look at the different rules for the trig functions. I will give you the rules, do an example, and give you a example of how we can prove one of these rules, because you most likely might get a question in one of your tests or your exam. So stay tuned and we'll get into the trig functions next. Okay, so now we're gonna head into the trig functions. Have your pen and paper close to you, as I'm going to give you the rules or properties for all of the trig functions. So take them down and use them. And I'll give you maybe one example or so, and maybe show you how to do the integral of tan. So let's go into it, right? So the first one is the integral of cos of x dx, and that's equal to sine of x plus c. Don't forget the c. Then we have the integral of sine of x dx, and that's equal to minus cos of x plus c. Then we have the integral of tan of x. So the integral of tan of x dx, that's equal to ln the absolute value of sec x plus c. Then we have the integral of sec x dx, and that's equal to ln absolute value of tan of x plus sec of x plus c. Okay, so let's go with the integral of cosec. So integral of cosec of x dx, that's equal to ln cosec of x minus cot of x plus c, and this can simply be written as ln tan of x by 2 absolute value plus c. Okay, so that's simplified. Then we have the integral of cot of x dx, and that's basically ln sine x plus c. Then the integral of sec squared x dx, that's equal to tan of x plus c. Let's go with the next one. So the next one is the integral of cosec squared x dx, that's equal to minus or negative cot x plus c. So let's go with the next one. So what is the integral of cosec x cot of x dx? That's equal to minus cosec x plus c. Okay, so let's find the integral of sine of kx dx. So we already know that integral of sine of x is minus cos, so that's equal to minus cos of kx over k plus c. And the final rule for now is the integral of cos kx dx, that's equal to sine of x. We know the integral of cos is sine, and similarly to the previous one, it's kx over k plus c. Okay, so these are the rules to remember, because when you do get trig functions, you can immediately identify what the answer should be, or what you should simplify it to, and then work out the problem itself. Let's do some quick examples. I'm going to do some easy ones for now and probably do a dedicated video on trig functions later on. So let's do the integral of cos 3x. Okay, so that's just strictly equal to sine of x, sine of 3x over 3. And if you want to do the integral of cos of 7x dx, that's equal to sine of 7x over 7 plus c. Okay, quite similar to the exponents. When you have a constant, you bring the constant to the denominator as well. So what if we have the integral of 14 sine 2x? So that's equal to 14. We take out the constant as we did with the multiplication rule, into sine of x. So sine is minus cos 2x, which is our constant, all over 2, which is our constant, plus c. And we can simplify this. Just remember to simplify. So that's equal to 7 into minus cos 2x plus c. Quite simple, right? So when you have the constant, bring the constant to the denominator as well, similarly to how we did with the exponential rule. As promised, to end this video off, I am going to take you through proving one of these trig functions. So the one function that we're going to try to prove is the integral of tan of x dx is equal to n of sec x plus c, or secant x. So in order to prove this, right, let's simplify, right? So let's look at the left hand side, which is here, and let's go for it with tan of x, right? So we know that the integral of tan of x dx can be rewritten. So tan can be rewritten as the integral of sine of x over cos of x dx. Now, very importantly, right, what do you think we should do here? When in doubt, use let's go ahead and use u substitution. So let's make cos of x equal to u. So let's make u equal to cos of x. That means that du is going to be equal to derivative of cos of x is minus sine of x dx. So our dx is equal to du divided by minus sine of x. Okay, so u substitution, best way to go right now. So if we substitute back into the original, we'll now have the integral of sine of x over u du over minus sine of x, and we can now see that the two signs of x can cancel out. So we now have minus the integral of 1 over u du, and at this point we know that here that the integral of 1 over x dx is equal to none of x. Okay, so if we apply this rule from what we previously learned, which was the reciprocal rule, we would now have this equal to minus ln of u plus c. And ln gives us the opportunity to move the minus inside, so this is now equal to ln into cos of x raised to the minus 1 plus c. Okay, so that's simply ln of 1 over cos of x plus c. And 1 over cos of x, so the inverse of cos of x, that's just equal to ln of sec x or secant x plus c. Okay, so this was basically a simple way of proving that the integral of tan of x dx is equal to ln secant x plus c. So this is basically the end of this entire video around giving you my integral cheat sheet. This will definitely help you on passing and getting through the integral section. Ensure that you have or noted down all of the different rules. Ensure that you don't miss out the C, and ensure that you do try to simplify as much as you can, because you would get an answer for your simplification. And don't forget, when in doubt, try to use u substitution to simplify the integral, and that will let you see or visually see which rules you would need to use in order to solve your integral. So until next time, look out for more of my videos, like and subscribe, and I'll see you soon on the flip side.